Hi everyone, it is Miss Nelson back with day 2, and today we're going to be talking about how do pressure systems cause wind. So to start, for your do now, I want you to think about what is wind and what causes it. So as we can see from this video, wind is the movement of air, right? But what causes it? So wind is the movement of air due to differences in air pressure. That is what causes wind, differences in air pressure. And what you need to know is that air moves from high pressure to low pressure. Why does air move from high pressure to low pressure? Well, to understand this, we need to imagine that we are in a subway. And there are two subway cars right next to each other. One subway car is really crowded, and the other subway car is emptier. What's going to happen if these two subway cars are right next to each other? We know that people will move from the crowded car to the emptier car because people don't like being crowded. The same is true of air molecules. So, air molecules, when they're crowded together, we call that high pressure, high air pressure. When they're more spread out, we call that low air pressure. Just like people in the subway, air molecules don't like to be crowded. So the air molecules are going to move from the high pressure location to the low pressure location. This movement of air molecules from high pressure to low pressure we call wind. And that's actually what we feel when we feel wind, is we feel all the air molecules brushing past us, going from the high pressure location to the low pressure location. And a couple things are going to affect air pressure. One is temperature. So I have a video for you, but first what you need to know is that a guy is going to be putting air balloons into liquid nitrogen. Liquid nitrogen is extremely cold. It is about negative 300 degrees Fahrenheit. The reason it is so cold is that, and remember, our air is mostly made of nitrogen, so it's like taking our air and making it so cold that it's liquid. It's no longer gas. When we watch this video, I want you to pay particular attention to what happens to the balloons when they're put in liquid nitrogen, when it is extremely cold, and what happens to them when they return to room temperature, when he takes them out of the liquid nitrogen. Alright, let's watch the video.
And today we're going to put balloons into the liquid nitrogen and let's see what happens. Okay, once again I got here liquid nitrogen. I'm going to put it in a bowl. Whole bunch of it. Look at that, so cold. Just a little bit more and that's it. Put that away. Okay, and now I'm just gonna put these balloons inside of it. Let's see what happens. Actually, I need something to push it in. Wow, look what happens to those balloons. That's so cool. Wow, this is so awesome. Too much fun. Wow, it turns out like a paper. They don't even pop, they kind of deflate. Oh, sink it all the way in. Wow, that's so awesome. Couple more. There's yeah. You definitely need to help it for it to deflate faster and sink it in. Let's try a bigger one. Well, I used a little bit too much of a liquid nitrogen. Maybe I'll just pull it back when I'm done. Wow, look at this. This whole big balloon is shrinking as well. Here you go. Oh, I got stuck. No, don't get stuck. Here you go. Whoa, this is insane. Do you hear it crumble up? So crazy. Okay, now what I'm gonna do is put it aside, and guess what? I'm just gonna pull them out and put them right here, and let's see what happens. Look at them. It's like Terminator 2. Remember that when he put back together the liquid one? Whoa, look at that. This is so awesome. Woo! One of them popped. That was kind of scary. Look, I can even hold it. And because I'm holding it, it's actually... Ah! Oh! That's so scary when they pop. That's kind of awesome. Well, some of them have popped. There's a big one. Let's see what happens. Will it pop or will it survive? This is so cool. What do you guys think? Go back to normal. No big deal. This is so awesome. Definitely a really cool experiment with liquid nitrogen. And look, it's back to normal. One more time. Look at it shrinking. So cool. It feels like just plastic. It doesn't feel like a balloon anymore. I'm gonna pull it out and put it in my hand. Okay, lift it up. See what happens. Look at it. My hands are warm. I made it up even faster. Wow, look at that side. So my hands are warm, so that's why it's coming back a lot faster. And there you go. A regular balloon. Awesome. Well, guys.
So, what we saw from that video was that warm air expanded. Remember, when he took the balloons out of the liquid nitrogen and it returned back to room temperature, which was much warmer, the balloons expanded again. That's because they have less pressure. So the air molecules spread out because they have less pressure, and that's going to cause the air to rise in the atmosphere. People who fly hot air balloons use this to their advantage. So if you take a look at that picture, you see people putting fire into the balloon, and that's to make the air inside hotter so that the balloon will expand out, the air will expand out, and that balloon, that hot air balloon, will rise into the atmosphere. Cold air is the opposite. So when we put the balloons in the liquid nitrogen, which was extremely cold, that balloon contracted, or it looked like it deflated. That's because the air has more pressure, so the air molecules are getting closer together. And cold air is going to sink in the atmosphere. So again, people who fly hot air balloons use this to their advantage. When they want to get closer towards the ground, they just turn off the fire. The air will get colder inside, and the entire hot air balloon will sink closer towards the ground. So now that we've talked about how temperature affects air pressure, we're going to talk about how humidity affects air pressure. So first, what is humidity? Humidity is water or moisture in the air. So if we look at this picture, we imagine we have all those air molecules, and if we notice, one of them is a water molecule. This would be low humidity. Because we only have one water molecule, there's not that much water or moisture in the air. Now imagine we have a lot of water molecules in the air, that would be high humidity. And that's what causes hair to get frizzy in the summer, is because there's so much moisture or water in the air. But how does humidity affect air pressure? To understand that, we have to understand which has more weight, a water molecule, or what would be moist air, or a nitrogen molecule, which would be dry air. And it turns out that the nitrogen molecule, or the dry air, has more weight. So humid air is lighter than dry air. Lighter means it has less pressure, it has less weight. So humidity will cause the air to have less pressure. Now we have to think about, how does air pressure affect weather? Often, if you guys have ever watched the weather on the news, you'll see a weatherman or a weatherwoman standing in front of a map that has H's and L's on it. So what you need to know is that the H stands for a high pressure system, and the L stands for a low pressure system. And at those locations, different things are happening with the air. So, a low pressure system, or what we also call a cyclone, in that case, warm, humid air is going to rise, and wind will blow counterclockwise and in towards the low pressure system. So remember, warm air, that's going to rise in the atmosphere because it has lower pressure. We just learned that with the hot air balloons. And humid air has less pressure because it doesn't weigh as much as dry air, so that also causes it to rise. And wind blows counterclockwise and in. At a high pressure system, we also call that an anticyclone. That is, cool, dry air is going to sink towards the high pressure system, and wind blows clockwise and out, away from the high pressure system. So remember, cool air, we have higher pressure, and that causes air to sink in the atmosphere. And dry air is heavier than wet air, so dry air is going to sink down into the atmosphere. We also remember that wind blows clockwise and out. Each of these pressure systems has weather associated with it. So, in the high pressure system, remember, air is sinking and blowing out. We usually associate that with nice sunny days. In a low pressure system, remember, that is air that is rising. When air rises, that the air gets colder and colder, we get clouds that form, and this gives us stormy weather. So it's either cloudy or stormy weather, usually that crummy weather, that is at a low pressure system. But you might be thinking, how am I supposed to remember that the air spins clockwise or counterclockwise, or which way the air is going, in or out? Well, I have a couple tricks for you to remember. So, your tricks for remembering which way the air moves and in what direction are the following. First, we have to remember that air goes from high to low pressure. To remember that, you can think back to the subway example, like people go from the crowded subway car, which represents high pressure, to where things are more spread out, the low pressure location. Then you have to remember that a clock is high and a counter is low. And what do I mean by that? Well, let's think back to my classroom. A clock is literally high up. It is above the doorway. In a classroom, we put a clock high up. And a counter is much lower. So this will help us remember that in the high pressure system, the air spins clockwise, or the direction that the hands on the clock spin. In a low pressure system, the air spins counterclockwise, or opposite the way that a clock spins. So now, in your notes, we can draw which way the air moves. So in the diagram, you can see I have a high pressure system and a low pressure system with the H and the L. And there's dots around each of them, and that represents a little section of air. So around the high pressure system, we can see that the air goes away from the high pressure system. That's because air goes from high to low. So it goes away from the high towards where there's lower air pressure. And that's out, away from the high pressure system. But it doesn't go straight out. That air spins as it goes out, and it spins in the clockwise direction. And the way we remember that is a clock is high. So in the high pressure system, the air spins clockwise. In the low pressure system, now the air is going towards the low pressure system because an air goes from high to low. So now the air is going towards the low. But again, it doesn't go straight towards the low pressure system. It spins, and it spins counterclockwise. And remember, the way you can remember that again is a counter is low. So for the low pressure system, it spins counterclockwise or opposite the direction that a clock spins. If you haven't already, please take this time now, and you can pause the video and draw the way that the air spins in your notes, just as I have on this diagram. All right, so that is our lesson for today. You may notice that we've cut off halfway through the note packet. So tomorrow we're going to continue with specific heat, local, and global winds. But that is lesson for today. Please remember to do your homework on Castle Learning. There is one assignment already posted, which is a practice regents. If you are having trouble logging on to Castle Learning, please let me know and I can help you out. I can either reset your password or help you log in. Also, please send me a message on Remind if you have watched this video. That helps me track who has access to internet, who has been able to keep up with the lessons, because soon I'm going to be making phone calls home to the people who have not contacted me. So please send me a message on Remind if you have watched this video. And also in that message, please let me know how and if you have the note packet. So if you have the note packet, if you've printed it off, or if you were able to get it from either the district office or the school office, and if not, whether you're taking notes on loose leaf paper. I have listed below the Remind codes, so you can see what the Remind codes are for all my Earth Science classes, period 1, 2, 4, and 7. And Remind is just the best way to keep in contact with me. So please download Remind, please send me a message if you have seen this video and the first video, and remember to do your Castle Learning homework, because soon I will be posting homework related to Unit 8, Weather. And I want to make sure everyone is on and ready to go. All right, I hope you guys have a good day. I hope you stay happy and stay safe, and stay tuned because more videos are coming your way. Bye!